Hello,
Hello,
good morning.
morning, sir.
So last time we discussed this question. Okay, let me just recollect. So ABC, A and B are positive numbers, positive real. Okay, and A1, uh, these are in AP. Okay, this is in GP, and this is in HP, and we have to show this one. So last time we showed this first part, first equality. Okay, this thing we didn't complete it. Okay, to show the first one, this is a step. G1 divided by H1 H2 equal to G1 plus H2 divided by H1 plus H2. This we show. Okay, so I'm bringing this A1 plus A2 here and writing this list. Uh, when things are in HP, it's easy to handle its reciprocals because the reciprocal will be in AP. Okay, so once I bring H1 H2 here, uh, we will get 1 by H1 and 1 by H2, which is easy to handle. Okay, and G1 G2 is AR to AR square because A G1 G2 B are in GP, and if R is a common ratio, then G1 is AR, G2 is AR square. Okay, so from that we'll get G1 G2 as AR into AR square, and then A we can keep like this, and R square will become R cube. So that will become B. A into R cube is B. Okay, this step is clear. And denominator is A1 plus A2, that is this one. That we can write as A plus B because A plus A2 is B. So A1 plus A2 is A plus B. So in AP, if you add the first term and the last term, and the second term, the last part, one term, it will be same. That's what it is saying. A1 plus A2 is equal to A plus B. Right, and yeah, this thing we have to show as this one, 1 by H1 plus 1 by H2. And since this is in HP, so 1 by H1 is 1 by A plus capital D. That capital D is the common difference of the reciprocal of the HP. So capital D is 1 by B minus 1 by A divided by 3. Is this clear?
Yes, sir.
Because capital D is the difference of the reciprocal of the HP. Okay, so it should be 1 by B minus 1 by A divided by 3. Because there are 3 steps to go from 1 by A to 1 by B. That is capital B. So again, this can be written as 1 by A plus 1 by B. And this thing is obviously true. So that means that this thing is true. This is what I did last time. Now we have to show this equality. The second one, that is A1 is equal to H2 equal to this one. Since this is equal to this this one which we already proved, since of A1 plus H2 by H1 plus H2, we'll use this one. So this one should be shown as equal to this one, equal to this one. Okay. So we just take G1, G2 divided by H1, H2 and see how it is simplified. So G1, G2 is A to B. So what we did from what? Is that clear? G1, G2 is this one. And the same as A to B. And then H1, H2 is 1 by H1 into 1 by H2, right?
Yeah.
And 1 by H1 is 1 by A plus D, capital D. So this is H1. And H2 is 1 by A plus 2D. 1 by H1. Sorry, 1 by H2. Is it clear?
Yes, sir.
And 1 by H2 I can also write as 1 by B minus D. Right? The last term, to get the previous term, I have to subtract D. From the first term to go to the second term, I have to add D, common difference, right? Similarly, 1 by H2 is same as 1 by B minus capital D. This way. Yes or no?
Yes, sir.
I can write 1 by H2 in two ways. I can write as A plus 1 by A plus 2D, or I can write as 1 by B minus D. Okay, I written as 1 by B minus D. Now I'll take A inside this one and B inside this one. So that will become, this will become 1 plus capital D is 1 by B minus. So this will become 1 minus B by E. Okay. Similarly, the next one I take B inside, so it will become 1 and then E by B minus 1 because minus D is 1 by E minus 1 by B. Okay. So this thing will, now it will simplify. 3 and 3 others will become 9 and then this thing will become 2 plus A by B, other is 2 plus B by E. This will become 2A plus B into 2B plus A divided by 9AB. That's what is big here. Okay. So now this equality is proved. Is it clear?
Yes, sir.
Okay. So whenever there is HP, you try to handle the reciprocals because that will be in AP. Okay. AP. What is an AP?
Sir, AP is a series where there is a common difference between two consecutive terms.
Yeah. So two numbers A and D will define AP, right?
Yeah.
If you fix A and D, then AP is fixed. Similarly, GP is A, AR, AR square. So if you fix A and R, the GP is fixed. Okay. Now if you have to represent AP by a diagram, I can represent like this. The value, the term number, and the value of the term again. So it will go like this. The first one will be A, and the second will be A plus D. This value is A. This value is A plus D. Okay. Next will be, so it will be like this. This is representation of an AP. Yes.
Yes, sir.
Y-axis value of the term. So what about this one? Is this an AP?
No, sir.
Why?
So because common difference is not equal.
No, it is equal. So this is A. This is A plus D.
Yeah, everything.
So is this an AP?
Yes, sir.
What is the difference between this and this? The first one, second one. Here it is coming down, right?
Yeah.
And here it is going up. So A plus D is greater than A, right?
Yeah.
Then why is it coming down?
Because common difference is negative.
Yeah. So here the common difference is less than 0, and here it is greater than 0. Okay.
Yeah.
Now suppose if I increase the D, then the step size will increase.
Yeah.
Okay. And if I increase A, the whole thing will move up, right?
Yes, sir.
Suppose A is 2 here and I change it to 5, so the whole thing will move by 3. And if I decrease A, the whole thing will move down. Okay. Same thing will happen here. If I increase A, if I decrease A, it will go up and go down. And if I increase D, the size of D still negative, then the step size will increase. So the AP can either be like this or like this, coming down. Things I can change is I can make the step size larger and I can shift the whole thing up and down. These are the only possibilities. Okay. So similar picture, if I draw for GP, GP will look like this. AR, A, the first term, the second term is AR, third term is AR, and the fourth term is AR cube, right? Okay, here the step size will constantly increase, right? Because this is A into R minus 1, this is AR into R minus 1. And what can you say about R here? Is it less than or greater than 1? R, is it less than 1 or greater than 1? Your mic is off.
So it is greater than 1.
So there is another possibility that R can be less than 1, right?
Yeah.
So for the same A, if R is less than 1, how will the plot look like? This is A. So A are the downward, no? Because if A is 2 and R is 0.5, it will go down. And what about the step size? It will keep on decreasing. Here the step size is increasing. In this
Sir,
case,
it will decrease over here.
yeah. So finally, it will reach saturate at infinity.
Infinite.
Sorry, it will reach 0 because the nth term is A into R is for n minus 1. R is a fraction, so fraction to a large number, so it will touch 0 at infinity. Is that clear?
Yes, sir.
Okay.
The same thing you had shown in the video.
Yeah, but I did not elaborate other possibilities. I just told these two first.
Yeah.
Okay. So now if R is, see here, both R are positive. Okay. But R can be negative also. Assume that R is negative, but the value of R is greater than 1, that is R is less than minus 1. Say. R is negative, but the absolute value of R is uh, greater than 1. So in that case, if A is positive, the second term will be here, negative. This is 0. The third term will be positive. Fourth term will be negative. It will oscillate. Getting it? And if R is less than 1, so that is R is in between, R is less than 0, but greater than minus 1. So R is a negative fraction. So again, it will oscillate, but it will keep converging towards 0. Got it?
Yes, sir.
Okay. And I'm assuming A is positive. If A is negative, means the whole thing will get reflected. The A is negative and R is greater than 1. So instead of this one, the whole thing will come down. Got it? A is negative, but R is greater than 1. So it is this thing which is reflected about this x-axis. Is it clear? Solve this problem. He is saying sum of infinite geometric progression is 5. So what does it say about R? That means R is less than 1.
R is negative.
Not negative, less than 1. Let it be
Yeah.
positive. Let it be positive only.
Yeah. Okay.
So this means x is equal to into 1 minus R. So you have to find the range of x.
Hello.
Yeah. You can do, right?
Yeah.
Yeah, try this one. Actually, R can also be negative. We don't have to restrict to the positive one.
Yeah, because
Minus 1 to plus 1. It should be a fraction.
yeah.
Basically, we are using the as 0 as n to to infinity. That will happen even if R is negative fraction. Getting the answer?
Sir, is it B?
Yeah. R is varying from -1 to plus 1. So you can say 1 minus R will vary from 0 to 2. Or you can say, or before that you can say minus R varies from -1 to 1. So 1 minus R will vary from 0 to 2. So X will vary from 0 to 10. Okay, and equal to sign is not included. Equal to sign is here. That won't be included because that means R is 1. That means that infinity into X is 5 if R is 1. Okay, so 1 is not included. Here the equal to sign is not included, so it's strictly less than. So that is the answer is B, not A. Okay. Okay, this one. 4 distinct positive numbers are in GP. Let me. So it is the sequence A1. This is 16C. Yeah. See.
So that was C was the only possibility.
Yeah. So B, the sequence B is like a sum of GP. First term, 2 terms, 3 terms, and 4 terms. So it's not this one. Infinite geometric series. Actually, it is sum.
Sir, K is greater than -1 and 1.
Only you have to find the value, no number. K is what?
K is less than -1 and greater than 1.
K is the index. It's 1 to 2, 1 to 100. You have to find the value of this one, that expression.
Hmm.
See, since it's a infinite geometric series, R is less than 1, the common ratio. Let us take the condition that common ratio is less than 1. So sum of K terms is why has he given this information? K equal to 1.
Yes. That's why I'm confused.
Yes, K sum of
And common ratio is also 1 upon K.
series.
Common ratio is a constant, right?
Yeah, it's 1. Okay, let's leave that thing apart. So he's saying the first term A is K minus 1 by K factorial, and the common ratio is 1 by K. Okay, the first term is second term will be, so the series is K minus 1 by K factorial. The second term will be K minus 1 by K times K factorial. This is correct. Sum of infinite terms is the first term divided by 1 minus r. So this is K minus 1, K minus 1. So it's 1 by K minus 1. Okay. K is greater than or equal to. Okay. Now, okay. See there are different series S1, S2, so on up to SK. Okay, and all these series are infinite. Okay, so this thing starts with some A, and it has got some R, and it has got infinite terms. Okay, and S2 is some other series. It has got some other different A, R, and then it goes up to infinity. Okay, so any SK, the sum will be the corresponding A divided by.
What is R? Is it the common ratio? 1 upon K.
See, there are K series, K different series. Okay, so each series
Yeah.
will have one particular A and one particular R,
Yeah.
and I called it A1. There is no confusion, right? A1, R1, and there is a second series which has got a different A, okay, and a different common ratio. Okay, all of the series are infinite series. So any particular K, if I take that thing, it will be that particular A divided by 1 minus R. Okay, so that K, the A1, the first term is K minus 1 for any series. It will be K factorial.
Okay. So we just substitute the value of K for each series.
See, the first series, the first term is 0 because you have to put K equal to 1.
Yeah. So it's 0.
Okay, all right. So let us write for the general K series. It's E is K minus 1 by K factorial, and 1 minus R is 1 minus 1 by K. So this is equal to uh, K minus 1 will cancel. K minus 1 factorial. Is this clear? That,
Yeah.
so for different values of k, the sum is 1 minus k minus 1 factorial, right? Yes. And for the first series, the first term is k equal to 1. First term is 0. Second term is also 0. Got it? The common ratio for the first series is 1, and the first term is 0.
Yeah.
Okay. So with the second series, the first term is k equal to 2, right? So 1 divided
Half.
by half. So the first term is half. The common ratio is half, right?
Half.
So it is 1 by 4, 1 by 8.
Infinite.
Yeah. So this is what is happening. So now we have to do the summation of k square minus 3k plus 3 into sk. So sk, the general expression is this one. Okay. So if you put this thing here, it will become k square minus 3k plus 1 into 1 by k minus 1 factorial. And you have to sum it for k equal to 1 to 100. Why have they given mod? This thing can become negative.
It can become negative.
This thing can become negative in between the
Yeah.
roots. So is it cancelling? The roots of this one is what? It's not easy.
Half. Half.
Half and
No, not half. Sorry. So discriminant is 5. So it has irrational roots.
okay. So from this we get S1 equal to 0, right? And S2
Yeah.
equal to A divided by 1 minus R. So S2 is 1.
Yeah.
And okay, that we can get from here itself. S1 is you have to put 1, 0 factorial is 1. S2 is you have to put 2, 1 factorial is 1. And S3 is
How is 0 factorial is 1?
0 factorial is 1.
So
Right now,
how?
right now you assume it. You will come to know later in the permutation and combination chapter.
Okay.
And 1 factorial is 1. That you don't have any doubt.
No, sir. I don't have any doubts for that.
Okay. 2 factorial is how much?
2 factorial is 2.
So S3 is half.
6.
S4 is 6. See,
Sir, 3 factorial is equal to 3 into 2 into 1, right?
yeah. See, Sk is 1 by k minus 1 factorial. So S4 is
Yeah.
1 by 3 factorial. That is 1 by 6.
Yeah.
So that we can use here. So S1 is 0. So k equal to 1, we do not contribute. K equal to 2, it is 1. So 2 square and okay, how has this simplified? He has taken 1 outside separately. So
So
he is
we
starting
from a AP.
here he has put k equal to 2. So 1 by, so this thing has factors. 1 is split into factors, it will get minus 3. Okay, yes, he has put 2 also because he is starting with 3. Okay, and he has used S2 as something. Okay, he's starting from 3. So when k equal to 3, so this thing has got k minus 3.
J advance.
Yeah, no, just one step is remaining. So this thing is basically coming out as k minus 3 factorial into k minus 1 factorial. No. K minus 1 factorial minus see what is K minus 1 factorial minus K minus 3 factorial? K minus 1 factorial minus K minus 3 factorial. So this is equal to K minus 3 factorial into K minus 1 into K minus 2 minus 1. Is this correct? This is K
Yeah.
plus 2K plus 2, sorry, yeah, plus 2 minus 1 plus 1. Is this correct? So K square plus 2K plus 1, sorry, minus 3K.
Yeah, -3.
That's what is written like this. K square minus 3K minus 1 can be written as this divided by K minus 3 factorial.
Okay.
That was he has done here. This thing is written as K minus 1 factorial minus K minus 3 factorial divided by this one. Again, he has taken out 2 separately. So it's starting from 3. Okay. And after that, he has put mod here. 0 factorial. Yeah, all are negative quantities because no, it's not negative because 3 factorial is large enough. It's always positive only. All the modes are positive, no? Because the second term is smaller because the denominator is larger. Right? So minus here will cancel the plus here. And then minus 1 here. Okay. So if you combine everything, only 2 things remain, 98 and 99. Okay. You have to do it carefully. See, one thing is mod is not required because all are positive. Because the second term is smaller. Okay. And things are cancelling here. Here it's minus 1 by 2 factorial. And here there is a plus 1 by 2 factorial. And minus 1 by 3, similarly there will be plus somewhere here. Okay. You have to check the pattern and then cancel it. And only 98 and 99 will remain. Okay. Do it. If you don't get it, I'll do it next time. Or just look at the pattern. But this is one crucial step. Unless you do it previously, you will not, I don't think you'll be able to figure out in the exam. This is something similar you should have already done. Okay. Another way is you can just see there is something as a function of k, right? Just put blindly k as some values and see whether you are able to get this pattern. Okay. Put k equal to 1 to 1, 2 is not a useful thing. From 2, 3, and then see whether you are getting a pattern. Because values of S2 and S3 have numbers. Okay. This one. Only these values, not everything. There are only 11 terms. Okay.
Sir, how 11 term?
Because he has given
9.
No, here there are 9, but totally 11, right?
Yeah.
So A1 square is 15 square, right? And A2 is okay. A2 has also some meaning is there for A2. then the value of divided by 11. So this means that A2 is less than 27 by 2. And this is means A3 is 2 times the previous one A2 minus A1. A3 is the maximum value of A2 is this one. So A3 is less than 27 minus A1 is so maybe you can get A4. Wow. This is a nice thing, right? Right. So you got it. See, this is an important step. Okay, this you can rewrite as this one, AK minus 1. So basically, this is what this is in AP. This is the definition of AP, right? The middle term is the average of the previous term and the next term. Okay, so this means that AR and AP. Okay, that's an important thing to realize. So since the 11 numbers are in AP, I'll take the middle one as A6. Okay.
Yeah, for the one AP only.
Yeah. So unfortunately, there are 11. So there is a middle term because it's an odd number of terms, right? The middle term is 6. So from
Sorry.
there, I'll write the other terms as A6 plus D and minus D. Okay. And the D is negative here because the second term A2 is less than 27 by 2, right? So that is so from A1 to A2 the value is decreasing. He has given this one, right? A1 is 15, so A2 is less than 27 by 2, that is less than 13.5. So here this implies that D is negative. Okay, so the value is decreasing. That's what is happening here. A6 plus 5D, A6 plus 4, right? And here it will happen that D is positive, right? Right. So and he has given the sum of 990 is what? 90 is sum of squares. Okay. So so you have 8 minus 5D and 8 plus. Okay, A6 for short you can represent as A. So you have A minus 5D and A plus A6 plus 5D. So when you square and add them, Yeah. So here you have a minus b and here you have a plus b. So a minus b square and then a plus b square. You get 2 times a square plus b square. Because 2ab minus 2 will cancel. Is that clear?
Yes, sir.
So we have a6 square 11 times. Okay. And then this d square, we have 5 square plus 4 square plus 3 square plus 2 square plus 1 square.
Yeah.
That you have a formula, sum of squares,
Yeah.
into n into n plus 1 into n plus 1 by 6. So from that you'll get 110. Okay. And this is
Okay,
equal
sir. I
to,
understood. So yeah, D will come 3, 9 by 7.
yeah. So once you know d, and then a is known
It is
to
simple. Yeah. A6 is 0. Okay, yeah, I got that.
yeah. And d 9 by 7 is 13.7, which is not possible because you've already given the condition that this is not possible. Right? So there is only one value of d. So now we can find it. This is trivial.
Yeah. Okay, sir. Yeah. Got it.
2010 JEE Maths was one of the toughest in the history of the exam.
Oh, okay.
This was set by IIT Madras. This is JE11.
Okay.
Okay, A1, A2, AP. A1 is 3. SP is, okay, summation of P terms.
A is equal to 3, right?
Yeah. This is independent of n.
And we use this SP is equal to.
So you have to find D. No, P is basically sum of P terms. That's not big deal. That's a very general statement.
There is thing, but P can lie between 1 and 100.
Yeah, because see, basically we have only 100 terms, no? And n is varying
Yeah, yeah.
between 0 to 20, and m is 5 times n. So m will vary from 5 to 100.
Yeah, yeah.
Okay, all these things are not. So if this thing is independent of n, then no, this is clear. No, this is simple. From
Yeah.
here, yeah, m by n is 5. This is also fine. And then 2a1 minus b. M is now.
2A minus D is equal to 0. How?
Oh, then only then n and n will cancel. See, one way to make this thing independent of n is if this thing becomes 0, then n and n will cancel, right?
Yeah.
Right. So, yeah. So 2a minus d, 5, and then here also 2a minus d is there. Yeah, just one more step. Right. For that to become, so that will get d is 6. Yeah, once d is known, everything is known.
Yeah.
This thing I should have simplified further. Not stop here. Yeah, just have only n separate. Yeah, one way to make it independent of n is to make n and n cancel. Right, this one.
So to find D, we just find difference between 1 upon 5 and 1 upon 25 and divide that by 20.
19, right? See, there will be
Yeah.
19 days, 19 steps, right?
Yeah, yeah. So that will be
There will
4
be the
by 25.
That will be the D of the AP. Yeah. So D should
4
be.
by 25.
So my guess is D should be negative. Only then it will become. See, D is negative. The AP will go like this, right? And 0 will
Yeah,
be somewhere here. So this is the thing we have to catch. The first time it's becoming negative, right?
yeah.
So D is uh, 1 by 25 minus 1 by 5 divided by 19.
19.
So this is 20.
4 by 25 by 19.
That big number is there, no? 25 into 5. Negative.
625. So 125.
No, 25 into
125
5
into
is
19 is
okay. So some crazy number. So what should happen is the
so 325.
nth term is 1 by A plus n minus 1 into D, right? So this should be less than 0.
Yeah,
And 1 by A is 1 by 5.
yeah. So we just use
D is negative.
no, we just get the value from.
Less than 0.
So, so that will be 125, right?
25, yeah, that's what.
125.
Yeah, and this is minus sign here.
Yeah, minus.
So n has to be greater than something because after that it is always negative, right? So this is 125. So 125 by 5. N minus 1. And this thing should be multiplied by 19 by 20. So this is 5 times. So 4. 19 by 4 plus 1. 19 by 4 is 4 4 are 16, right? So it is 5 plus 3 by 4. Uh, yeah, I think I made a mistake here. 25. No? Silly mistake. 25 plus 3 by 4.
So what is that?
No, I made a mistake here.
I didn't understand that step.
Up to this is correct, no?
Yeah,
Okay. So it is 25 into 19 by 20. So it's a little bit less than 25, right?
yeah.
It's 25 minus something. And n should be greater than n is a full number, natural number. 22 it's D. Correct, no?
Okay, sir. Then.
If you only can calculate exactly, it should be 24 point something. And n should be greater
Yeah.
than 24. Yeah. This
Okay,
one.
sir.
Okay, you want to close now?
Okay, sir.
There are other problems. Do you have time to revise or not? You're doing with the coaching only.
Sir, actually, the coaching people they are going a little slow because ICSE students have boards, so they have
Okay.
to prepare for 10th also. So they will go a little bit slow.
Okay, in your batch there are ICC students.
Yeah.
Okay. Okay, fine. Then if you have time, you look at these things.
Yes, sir.